We are doing numerical values and verifying identities. Instructions for the first 5 problems. We need to find the exact value on the interval where x is between 0 degrees and 90 degrees inclusive. So if x is between 0 degrees and 90 degrees inclusive, that means x terminates in which quadrant? Quadrant 1. So all 5 of these examples, we're talking about an angle terminating in quadrant 1. Now problem number 1, we're given that the tangent of x is equal to 3, and we need to solve for the cotangent of x. Well, I already know that tangent and cotangent are reciprocal identities. So if the tangent is 3 over 1, what's the reciprocal of 3 over 1? 1/3. So number 1, the answer is 1/3. Next one, problem 2. We're given that the sine of x is equal to 5/13, and we need to find the cosine of x. Now, I need to tie this together with some of the identities that we learned last week. So I know an identity with sine and cosine would be sine squared plus cosine squared is equal to 1. Make sure you have that one memorized for our test coming up. Now, using that equation, substitute in what we know. So instead of sine, what should I substitute in for sine? 5 over 13. And sine needs to be squared plus cosine squared equals 1. Make sure you square both the numerator and the denominator. So 5 squared is 25. 13 squared is 169 plus cosine squared is equal to, instead of 1, what could I put instead of 1? 169 over 169. That way when I subtract 25 over 169, we already have a common denominator. So that gives me cosine squared is equal to 144 over 169, square root both sides, and that means the cosine is equal to 12 over 13. Now, if you use an identity, it's a long way to get to your answer. So the identities do work because the identities are true statements. But what's a faster way I could have done that? Draw a diagram. Draw the diagram. So I know that all of these angles terminate in quadrant 1. So draw your right triangle. Here's x. And they gave us the sine. I know sine is opposite over hypotenuse. So the opposite side is 5. And the hypotenuse is 13. And that would be a Pythagorean triple, so what's the missing side? 12. So if I want the cosine of x, it's just the adjacent over the hypotenuse, and the adjacent side would be 12. The hypotenuse would be 13. So what's faster, using a trig identity to solve or using our right triangles? Right triangle. So from here forward, I'll use a right triangle, but do know that you could use an identity and it would work as well. Next one, number 3. Again, all of these angles terminate in quadrant 1. So draw your right triangle. And if we're given cosine, we know that cosine is adjacent over hypotenuse. So the adjacent side is 2, the hypotenuse is 3. Is that a Pythagorean triple? No. So this one we will have to use Pythagorean theorem to find that missing side. So a squared plus b squared equals c squared. A and b are the legs, so I'll use 2 squared plus b squared equals hypotenuse squared. 2 squared is 4 plus b squared is equal to 3 squared is 9. Subtract 4 to both sides. b squared equals 5. So that means b is equal to square root of 5. So our missing side is square root of 5. All of that work, and what were they asking us to find? Tangent, and I know tangent is opposite over adjacent. So what's the opposite side? Square root of 5. Adjacent is 2. So the answer is square root of 5 over 2. Next one, number 4. Again, draw a diagram. It terminates in quadrant 1. Here's angle X. And we're given cosecant. Cosecant is the reciprocal of what? And I know sine is opposite over hypotenuse. So when I invert the fraction, this would be hypotenuse over opposite. So the hypotenuse is 5. The opposite is 1. How do I find the missing side? Pythagorean theorem. So that would be a squared plus b squared equals hypotenuse squared. So this will be 1 squared plus b squared equals 5 squared. 1 squared is 1. 5 squared, 25. Subtract 1 to both sides. B squared equals 24. So that means b equals the square root of 24. And should I leave it like that? Yeah, this would be 2 square root of 6. So the missing side is 2 square root of 6. And they're asking us for the secant. Well, secant is paired with cosine, and cosine is adjacent over hypotenuse. So this needs to be hypotenuse over adjacent. So for the hypotenuse, what would I use? 5 over 2 square root of 6. Can I leave that as my answer? Rationalize. So both in the numerator and denominator need to be multiplied by the square root of 6. So that gives me 5 square root of 6 in the numerator. Yeah, 2 times 6 would be 12. So 5 square root of 6 over 12. Okay, I want you to do number 5. Okay, we'll have to use Pythagorean theorem to find that missing side. So this would be a squared plus b squared equals c squared. So 7 squared plus b squared equals 11 squared. 7 squared is 49. 11 squared is 121. So what's 121 minus 49? So should I leave this as b equals the square root of 72? No, 36 times 2. So when you simplify that, it would be 6 square root of 2. So the adjacent side is 6 square root of 2. And here, what were they asking us for? And I know that tangent would be opposite over adjacent. The opposite side is 7. The adjacent side is 6 square root of 2. Can I leave my answer like that? Rationalize to multiply both the numerator and denominator by square root of 2. So our answer will be 7 square root of 2. And 6 times 2 is 12. So 7 square root of 2 over 12. Now the last three problems, we are verifying those identities. So when you are verifying, you can start with either the left side or the right side. You get to pick which side you're working with. And then once you choose the side you're working with, you'll need to work with that side only and prove that it equals the other side. So let's look at number 6. Number 6, do we want to start with the left side or the right side? Okay, let's go left to right. So rewrite the left side. On the left side, we have cosine of x over 1 plus sine of x plus cosine of x over 1 minus sine of x. Now, it's been a day or two since we've done some of these verifying problems. So when we are working these proofs, what are some things we can do to solve these? Convert everything to sines and cosines, but that won't help us in this problem. It's already done. Look to see if there is a Pythagorean identity. So we have ones, but do we have a square term? No. Factor, can anything factor there? No. So here, in order to add two fractions, we'll have to have a common denominator. So our common denominator, just multiply the denominators together. So it's going to be 1 plus sine of x times 1 minus sine of x. Now the first fraction had the 1 plus sine x. So what is it missing? 1 minus sine of x. So that means cosine of x needs to be multiplied by 1 minus sine of x. And for the second fraction, it has the 1 minus sine x. So what is it missing? So that means cosine of x needs to be multiplied by 1 plus sine of x. Next thing, we need to go ahead and distribute. So we need to distribute our cosine. And notice for the second fraction, we're distributing a positive cosine of x. Okay, so let's start distributing. What's cosine x times 1? Cosine x. What's cosine x times negative sine x? Negative cosine x sine x. Distributing the second cosine x, we already said cosine x times 1 is cosine of x. And cosine x times sine x is cosine x sine x. And in the denominator, what's 1 plus sine of x times 1 minus sine of x? 1 minus sine squared of x. And when we combine like terms, negative cosine x sine x, positive cosine x sine x, 0 pair. So the only thing left in the numerator is cosine x plus cosine x, which would be 2 cosine x. And what is 1 minus sine squared equal to? Cosine squared. That's a Pythagorean identity. And then our last step, cosine x in the numerator will cancel with 1 factor of cosine x in the denominator. So that leaves us with 2 over cosine x, and that is equal to what? 2 secant of x. Two more problems. Next one, problem 7. Number 7, do we want to go left to right or right to left? Yeah, let's do left to right, because if you'll notice, the left side we have 1 minus cotangent to the 4th power of x. And what is that called? A difference of squares. So if it's a difference of squares, what can I do with it? Factor it. So when I factor it, it would be 1 plus cotangent squared of x and 1 minus cotangent squared of x. Yeah, notice we have a 1 with a term that's squared, so that's a Pythagorean identity most likely. So let me do my scratch work over here in green. Sine squared plus cosine squared equals 1. If I have cotangent squared, what do I have to divide by? Sine squared. So divide all 3 of these by sine squared. Sine squared divided by sine squared is 1 plus cosine squared divided by sine squared, cotangent squared, and 1 over sine squared is equal to cosecant squared. So instead of 1 plus cotangent squared, what can I replace that with? Cosecant squared. Now after that, you might think that we could change everything to sines and cosines, but that's really not going to be helpful because notice my answer has cosecant squared. But we have a 1 cosecant squared. What do we have in our answer? 2 cosecant squared. So somehow I have to get another cosecant squared involved in this problem. And also looking at our answer, do we have a cotangent squared in the answer? No. So let's go back to this identity. And instead of cotangent squared, what could I replace that with? Cosecant squared minus 1. So that's the new thing for today. If you have a term that is squared, you can replace it with a Pythagorean identity. So over here, the cotangent squared, we're going to replace it. And instead of cotangent squared, what could I put? Cosecant squared minus 1. So let's go ahead and distribute that negative. So this would be 1 minus cosecant squared x. Right here I multiply negative 1 times cosecant squared x. Got negative cosecant squared x. And one more time, negative 1 times negative 1 would be positive 1. And if I combine like terms, 1 plus 1 would be 2 minus cosecant squared of x. And what's my last step? distribute. So when I distribute, what's cosecant squared x times 2? Cosecant squared x. And what is cosecant squared x times negative cosecant squared x? Negative cosecant to the 4th power of x. So we started with the left side, and we have proven it does equal the right side. One more. The fun continues. One more time. Number 8. Do we want to start with the left side or the right side? Left side. We have secant to the 4th power of x minus secant squared of x. Now, you could look at that and notice that it is a difference of squares, but what could you see before that? Factor what? Yeah, there's a GCF. So take care of the GCF. So first step, factor out the GCF. And when I factor out the secant square, what goes in the parentheses? Secant squared of x minus 1. That's an identity. So let's see what we have with secant squares. And the reason why I should be thinking identity, if you look at our answer, do we have secants in our answers? No. So we need to get rid of the secant, and we need to get cotangent or tangent. So let me change to green. Let's do sine squared plus cosine squared equals 1. If I have a secant squared, what would I have to divide by? Cosine squared. So sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared would be 1, and 1 over cosine squared would be secant squared. So over here, I can replace both of these secant squareds So both of these are going to be replaced. So instead of secant squared, what do I need to put? Tangent squared plus 1. And inside the parentheses, instead of secant squared, tangent squared plus 1. And then what's behind that secant squared that we just replaced? Minus 1. So what happens there? Yeah, positive 1, negative 1. That's a zero pair. So that's just tangent squared of x plus 1 needs to be multiplied by tangent squared. So here we'll have to distribute. Really, the parentheses needs to go over here now. That way we can distribute. Because over here it's really tangent squared of x plus 1. That needs to be multiplied. Distributing the tangent squared of x times tangent squared of x is tangent to the 4th power of x. And one more time, tangent squared times 1, tangent squared of x. Is that what we wanted? No, but it's close because we have 1 over cotangent to the 4th plus 1 over cotangent squared. Well, I know that tangent and cotangent are, yeah, they're reciprocal. So instead of tangent to the 4th power, I could put 1 over cotangent to the 4th power of x. And instead of tangent squared, I could put 1 over cotangent squared of x. And we have now proven that the left side equals the right side. So really the only new thing for today with the verifying is that if you have a squared term, you can replace it with a Pythagorean identity. Like what we did here. Instead of secant squared, we replaced it with tangent squared plus 1. You need notebook paper for your homework, so all work needs to be done on your own notebook paper.